This video deals with problems in inverse trigonometric functions. It shows us how to evaluate simple inverse trigonometric functions. We revise the domain and range of the various inverse trigonometric functions. So domain of sine inverse is the closed interval minus 1 to 1. Range is the closed interval minus pi by 2 to pi by 2. Domain of cos inverse is the closed interval minus 1 to 1. Range is the closed interval 0 to pi. Domain of tan inverse is R. Range is the open interval minus pi by 2 to pi by 2. Domain of cot inverse is R. Range is the open interval 0 to pi. Domain of sec inverse is R minus the open interval minus 1 to 1. And your range is the closed interval 0 pi minus pi by 2. Domain of cosec inverse is R minus the open interval minus 1 to 1. And the range is the closed interval minus pi by 2 to pi by 2 minus 0. Find the principal value of sec inverse 2 by root 3. We start with let sec inverse 2 by root 3 be equal to y. So sec y is 2 by root 3, cos y is root 3 by 2. Cos of 30 is root 3 by 2, so y is 30, which is pi by 6 radians. Evaluate tan inverse tan 9 pi by 8. Domain of tan inverse is the open interval minus pi by 2 to pi by 2, where we measure the angles in the anti-clockwise direction. 9 pi by 8 is pi plus pi by 8, which lies in the third quadrant. So we write tan pi plus pi by 8 as tan pi by 8, and it would be positive because in the fourth quadrant, pi plus pi by 8 is the third quadrant, tan is positive. So tan pi plus pi by 8 is tan pi by 8. So tan inverse tan 9 pi by 8 would be tan inverse of tan pi by 8, which is pi by 8. And pi by 8 lies in the first quadrant, which lies in the domain of tan inverse. Cos inverse of cos minus pi by 6. Now cos minus theta is cos theta. So this is cos inverse of cos pi by 6, which is pi by 6, because pi by 6 lies in the first quadrant and the domain of cos inverse is the closed interval 0 to pi. Now sin inverse minus x is minus sin inverse x for all mod x less than or equal to 1. Cos inverse minus x is pi minus cos inverse x for mod x less than or equal to 1. Tan inverse minus x is minus tan inverse x where x belongs to R. Cot inverse minus x is pi minus cot inverse x where x belongs to R. Cosec inverse minus x is minus cosec inverse x where mod x greater than or equal to 1. And sec inverse minus x is pi minus sec inverse x where mod x is greater than or equal to 1. So evaluate sin pi by 6 minus sin inverse minus root 3 by 2. Sin inverse minus theta is minus sin inverse theta. So this becomes sin pi by 6 plus sin inverse root 3 by 2. Sin 60 or sin pi by 3 is root 3 by 2. So sin inverse root 3 by 2 becomes pi by 3. So this becomes sin pi by 6 plus pi by 3, which is sin pi by 2, which is 1. Evaluate tan inverse tan 5 pi by 6 plus cos inverse cos 13 pi by 6. Tan 5 pi by 6 is tan lies in the second quadrant. Second quadrant lies outside the range of tan inverse because the range of tan inverse is the open interval minus pi by 2 to pi by 2. So you write 5 pi by 6 as pi minus pi by 6, which is minus tan pi by 6 because pi minus pi by 6 lies in the second quadrant. Second quadrant tan is negative. So tan inverse minus tan pi by 6 becomes minus tan inverse tan pi by 6 because tan inverse of minus tan inverse of tan theta is so this becomes, because tan inverse of minus theta is minus tan inverse theta. So this becomes minus tan inverse tan pi by 6, which is minus pi by 6. Now cos inverse of cos 13 pi by 6, 13 pi by 6 would be 2 pi plus pi by 6, which lies in the first quadrant, which is in the range of cos inverse. So cos inverse of cos 2 pi plus pi by 6 becomes cos inverse of cos pi by 6, because in the first quadrant cos is positive. And cos inverse of cos pi by 6 is pi by 6. So your answer would be minus pi by 6 plus pi by 6, which is 0.